Hello, everyone. Before we begin, I want to say thank you for sacrificing your lunch break, or alternatively, good on you for figuring out how to wait out the lines between 12 and 1 for food outside. But it's good to see you all. My name is Chris Murphy. I am a senior technical artist at Epic Games on the developer relations team, and my job is helping studios. There's a few familiar faces here that I've seen in various talks and events before, so some of you have heard this spiel. But essentially, my job is working with different studios to kind of solve problems. And while this talk is called Preempting Challenges in AAA, there's definitely going to be some challenges and, pitfalls to watch out for that you're going to be familiar with regardless of the size of your studio. Turns out some things are just issues in general. Who knew? But I really want to go into this, and I want to flag that this is one big presentation of, like, have you thought of this? And to that end, it's not necessarily a checklist. It's not like it's not something that is necessarily being enforced. What I really want to stress with this is, like, ultimately, you can generally be confident that your team has hired smart people who are making smart decisions, but a few of you pulled faces at that. But in doing so, sometimes even the smartest people still need to have certain things flagged with them because they're not, they don't have all of the facts when coming to certain other decisions. So this talk is really going to be highlighting a whole lot of things that's pretty broad spectrum. And while it is listed on the programming track, we're going to be jumping all over. I'm also going to flag that one thing I'm not really going to be touching in this talk is going to be the DevOps side of things. So I'm really going to be focusing on things to be aware of inside of the editor space and development space in particular, and things for your team to be aware of. But we have enough tools that, like tools talks that go on with DevOps that I think we should be good on that front for you to go down that rabbit hole as necessary. And I want to go in with project setup considerations. By default, Unreal has a bunch of config settings, and they're good. Things work out of the box. You load Unreal, and you're generally in a pretty good spot. But you don't always want those project settings for a larger scale project. Like some of the things that make life easier are also not necessarily easier when you've got 100 artists or something working on your team. So I wanted to go through a couple of project settings that I personally think you should consider. The first of those is if your project's not using static lighting, just turn it off. When allow static lighting is set to true, it actually stops the material AO contribution node in the material editor. I think it plays havoc with bent normals, if I remember correctly. There's a few aspects like that if you don't need it, get rid of it. It's there on by default so that, you can immediately start a project with any kind of lighting model you like. But there are perks to not having it on if you don't need it. And in addition to that, you can get rid of some extra shaders that would have otherwise compiled. The other one here is automatically set usage flags. So whenever you create a material and you apply it to something, by default, Unreal goes, hey, I've put this material on a spline mesh. And because of that, I'm going to now build permutations from now until forever that includes what to do with spline meshes. And that's fine, except if you have an artist, again, I'm sorry I'm actually kind of picking on the artists in this conversation here. Like, usually the engineers are the bad guys in my analogies, but we'll get there eventually. But no, if you have an artist one time who's like, hey, I wonder how this looks, and they drop a material onto a spline mesh, and they save it, you're kind of handling all those permutations for no good reason, especially if they immediately hit Control Z or Z to undo it. So because of that, you really, turning this off by default means that if you want to use it on spline mesh, you have to actually say this is used on spline meshes, or you're just going to get a world grid material. But when you have lots and lots of people working on things, go for it. These are settings that are now 5.5 by default, that are just, if you have a project that has nanite by default, that's going to be using nanite aggressively, reverse index buffers to false, depth only buffers to false. I want to flag this though, because remember that if your project was created on a previous version of Unreal, you'll be migrating your current config settings up, which means if you happen to have spun up a project on like 5.3, these settings may not be what you want them to be, even though it is the new default. Other things to just be aware of are support hardware ray tracing to true, which I think is now default in 5.5. Be aware that if you enable ray trace shadows at the project setting level, then any light which has project default set on it is going to have that, which is expensive unless you have Megalights running, but Megalights is experimental, so we're all going to have to play it cool on that for a little bit. Disable DX11 support if you're not going to use it. And the other one that I want to flag on the project settings is tick animation on skeletal mesh init. Now, I'm going to go into that one on a separate slide here. So by default, when you get a skeletal mesh and you play it, like you spawn something with a skeletal mesh in the world, what Unreal does is, while most animations play async, they're calculated off the game thread, because you're playing it for the first time, it kind of goes, oh no, we need to handle this right now so it doesn't T-pose. So it spends that first frame forcing that animation to go into the game thread, which means that you end up with potentially hitches if you have a bunch of skeletal meshes spawned at the same time that are all not doing what they would usually do, which is gently distribute those animations across a bunch of threads, and instead it forces them all together. So I kind of want to highlight that, because instead, if you do a little bit of extra elbow grease and you just handle skipping the first frame of rendering, you can kind of avoid the T-pose that you will see otherwise, but in doing so also avoid the hitch that would potentially be there. Just while we're on the subject of animations, I want to have a couple of call-outs here. The first of those is motion matching, and that is that despite our initial example for motion matching being 500 and something animations, be aware that you can get a pretty good motion matching setup from just 14 animations, and you can build from there. There is actually a sparse set in the sample if you want to see what that looks like, and I do strongly recommend teams to investigate that. In general, aggressively keep things in the blueprint thread safe function to reduce as much friction as possible. And remember that retargeting doesn't require runtime retargeting. Often when we discuss this feature, people are thinking of like two mannequins passing their animations between one another, but you can bake out animations if your studio has had to change its skeleton at some point during production and you don't want to handle large-scale re-export, or you can't because of legacy reasons. The other thing that I want to go into here, which is one of my denser slides, is that I just want to have a bit of a list here of things that can move a character onto the main thread. This is just my animation callout section, but be aware that if you do find that your characters are quite expensive and they're being moved to the main thread, which is slowing things down, if you've got root motion from everything, the engine basically says, they've checked this checkbox, which says every animation they play is going to move my character, which means I should never do it asynchronously because it's always going to mess with my movement, right? And a lot of people flick that checkbox on when they're first trying to get root motion working, because they're like, that'll probably work. And they'll get the visual result that they want, but they don't quite realize what the damage is from doing that checkbox sometimes. In general, there's that, and calling a non-thread safe function within the anim graph is going to do it as well. We throw warnings for that. Honestly, if you really want to deep dive on this topic, I strongly suggest you look at the copy term defaults to default object setup, and in there you can see all of the things that will move it across, and potentially, dance around them as required. So this is a slightly more contentious side, which is, while project settings and configs and stuff are things that we're like, hey, you probably normally want to change them, these are engine changes that I only really recommend to larger teams that have kind of the ability to micromanage these things. And that is because you'll need to do a source code change to do these ones. The first of those is potentially setting evaluate world position offset to false. And that means that any object that you want to have doing vertex animations, you've very explicitly said, I want that on this object. So you're kind of opting in rather than opting out. Can step up on and can affect navigation to false means that your navigation pathways are very explicitly set. And again, if you've got a larger team that has an LD who's very focused on that kind of stuff, then they can kind of, really cut back that overhead. It being true by default means that things just work. when you're first building these worlds. But the kind of project you're after can change that. The other one is have validation for material has WPO and evaluate WPO, just so that on the material level, it has to be opted into there as well as being opted into on the primitive itself. And finally, use simple collision as default. One other engine change I wanted to touch on this front that I think is a good idea to consider is we have a section of our context menu. And I want to highlight that I think this is being made easier in 5.6. Spoiler alert. But it's not quite there yet, so your team may want to do it. And that is that, to be blunt, if you have things that you want your team using more than other things, just make it a little bit more difficult for them to get to the other things. Like if you have, most AAA teams have a very material instance heavy pipeline, and they don't actually want their artists creating materials unless it's, for very specific things. So if you want your artists making material instances all the time, if when they right click, the thing that they see is material instance, and to get to, material, they have to go a few extra clicks. It's just like a gentle push in the right direction. And, by the same token, if you don't want them creating new blueprints because you want them to work within the gameplay ability system, gently pushing them to have right-click gameplay ability, gameplay effect, rather than blueprint to try and push things into those areas just means that you naturally direct people into the right place. A common thing that I see a lot, just as a person who kind of plays doctor on a bunch of these projects and trying to fix things, is that often I will recognize your console variables, which really says a lot about me as a human being. But I'll spot your CVars as being familiar from Epic Games projects. And what that says to me is like, someone's opened the project and been like, that's a good setting to have, I guess, because Epic did it. But we usually have a pretty good reason for what we've done most of the time. So what that means is I really wanted to just highlight some ways that you can investigate that further. First off, any CVar in the game, any CVar in the engine, if you type it in and then put a question mark at the end of it, it will just tell you what it does. So you don't have to just like arbitrarily change the numbers to figure out what's up. Again, another way that you can look at this is the console variables tool. Console variables tool allows you to easily flip between different CVars, and you can actually see where the CVar is currently being set from. So you can see whether it was on initialization, whether it was an override that you've currently put in for this current session. And you can also save out CVars, which is really good for folks who are looking for, whenever you need to debug a certain thing, you want to have these 5 CVars enabled. It's nice to be able to just be like, give me those 5 CVars. So I wanted to highlight this because it is really useful. The final on the CVar conversation is A/B test. And that is that if you type in A/B test before any console variable, and then after that variable, you type in the 2 numbers you want to check, Unreal will flip between the 2 options over and over again. And in the console, it will actually tell you the it'll tell you the performance difference, and it will tell you the percentage chance of that being from like random noise rather than it's probably from the variable. Just by doing it so many times, it'll be like, we're consistently seeing improvements here. And that can be really good for scoping things out. And at the same time as it's happening, you can kind of eyeball it without having to be like hitting tilde up enter. You're all nodding because you've been that person before. Like, is this good or not? We automated this action, so that's good. Another one is just honestly like, I feel like it's pretty common that you can spot default settings if you've been around Unreal enough, and one of the most common ones for them is TSR and Lumen. I don't think enough teams really tinker with these values, and I just wanted to point out that the TSR and Lumen settings are really, really heavily commented. That's been something that's been improving a lot with each release, but also that there's a really good document online that is frequently asked questions for TSR. And a lot of folks just don't know about it. And that doc really goes into just all sorts of common problems that people see from ghosting. Because like our values work really well for, our defaults, but there's quite a lot of just common problems that you want to iron out. And that doc really goes into it. But it's kind of its own separate talk almost that would need too many GIFs for me to capture. So you just get me pointing at it. A couple of plugins you probably want from the start that are not enabled by default for larger projects. Asset referencing policy, MVVM, PCG framework, and all of the relevant interops. GeoScripts, like these are all pretty self-explanatory. The only one here that I suspect folks don't know about is the asset referencing policy. And I say that because when I Googled it, I found that there was like 3 results online. Asset referencing policy means that you can create content in your developer folder, and it runs a data validation that when you try and reference things from your dev folder in your game folder, it says no, which is a great way to encourage your developers to use the developer folders, but also shake your finger at them vicariously and make sure that they're not sticking their prototype assets and things into your project. So it is pretty handy. I do recommend you looking at it. Plugins you probably know more from the start. Just disable all of the version control methods you're not using. Custom mesh component, procedural mesh component, media compositing, GLTF, variant manager, and paper 2D. Again, you know, if you have a reason for these, then so be it. They're on by default to make life easier for certain folks, but there's a good chance. That it's not something that you're diving into. In particular, custom mesh and procedural mesh, I strongly recommend flicking them off because we have dynamic mesh. We just kind of keep giving them similar names, right? But dynamic mesh should really be the one that you're after these days, and it's there for legacy reasons, but yeah. Your engine folder, just make sure it's at the P4 root, and you can put project folders in subfolders, but if you do, just remember to set up default.uprojectors and have it in there, just so that various DevOps tools and such work correctly. Otherwise, it's just an expectation that Unreal has. So next I want to focus on getting the most out of in-engine source control. So this is something that we strongly encourage teams to pursue. There's a lot of people who used in-engine source control in early UE4, and then they were like, never again. And that's fine, I get you, I was one of them. And honestly, it took the engineering team a little bit of convincing to really win me over, but they did win me over. And the more you're able to get your developers using this, the better. Aside from things like one file per actor being built around it, having easy ways to do uncontrolled change lists so that when a developer creates a bug, they can shelve that repo case immediately and pass that off to programmers is just it's just really nice. You know, like you can remove a lot of friction from the workplace. Instead of like having to describe a repro case, you can just give it to them and then move on with your life. Also, in-engine blueprint and asset diffing is getting better and better and better with each version, which kind of leads me on to the review tool. So in 5.4, I think, we added the review tool. The review tool is really cool. It actually lets you look at any change list and then see all of the changes that were made in that change list. And you can kind of flick between different assets to diff the blueprints, diff the assets themselves. And I do want to highlight that just on the diffing side of things, you know, when I say we're adding support for stuff, that includes things like state trees now. So you can actually see 2 different state trees next to each other and figure out what went wrong. Useful. But this is a tool that I think has snuck by quite a few people. So go for it. These are the top systems that I kind of like raise my eyebrows at, which is to say, like, I get why sometimes you write your own, but I'm still going to do this as you tell it to me until I like hear the reason as to why, just because it can commonly get folks into trouble. The gameplay ability system is a big one. I think a lot of folks look at Unreal. For anyone that's unfamiliar with it, the gameplay ability system is kind of a juggernaut framework that we have under the surface that people don't really talk about enough in Unreal. That is a full framework for handling abilities. So if you want to do like fire damage and give protection spells and then damage over time from that, but then someone puts water on you and that turns off the fire spell. Sorry, I'm looking at this one set of people over here in particular with my fire spell discussion. But for that kind of discussion, that whole system is really, really powerful. And quite often folks look at it and they're like, I think we'll build our own. And especially when they're coming from proprietary to Unreal, because they've got that experience, they've got that engineering experience, and I totally respect that. But an advantage of using Unreals, if you can make it work for your team, is honestly just on the hiring front. It's really convenient that you know that you can pull people in, and there is a good chance they're already incredibly familiar with working with the gameplay ability system from previous jobs. There's a bunch of our inbuilt gameplay debugging tools that are built around making the gameplay ability system easier to debug and figure out what's going wrong. Recently, one of our devs, Jikang, just put up a really good gameplay abilities debugging document that I strongly recommend if you are looking at that. Character movement component is another big one. I get why you do it, especially with Mover 2.0 coming in. It makes some sense in some situations, but for the producers and tech directors out there, if you do hear people avoiding character and CMC, I just want you to be like, are you sure this is a good idea? And really double down on checking that. Because the people, they want to go out and write their own logic for that. Sometimes it's a good idea, but sometimes not so much. Asset registry, for any folks that are unfamiliar with it, whenever you declare something in C++ and you have the variable set as asset registry searchable, Unreal builds a database under the hood of that thing, and you can then search it. And a lot of people actually go off and they end up creating their own spreadsheets that are like, this asset has this level of power, this asset has this level of power. But if they literally just declare that variable in the class as asset registry searchable, it now means that you can, in Blueprint or C++, be like, give me every weapon with level 4 power or above, and it will do that. And I bring this up because micromanaging and mishandling of data is terrible. It's so easy to fall into. And the more you're able to just automate that, in my opinion, the better. Data-driven CVars are... it's a name that catches people off guard, but essentially in the project settings, you can define your own console variables, and then there's a subsystem for catching those console variables and changing things in the game really easily. A lot of people miss that. And finally, the gameplay debugger. If you hit the talking marks on your keyboard, it'll launch up the gameplay debugger. And there's a lot of stuff in there for just immediately debugging nav that people kind of miss, and they write their own gameplay ability or EQS or behavior tree debugging tools around it. And I'm like, we did it already. And I just know that in future as well, the recent gameplay camera system that we've added and Mover 2.0 are probably going to end up on that list. So yeah, like I said, it's not necessarily saying don't definitively use all of ours for those. I just want the tech directors and producers in the room to just kind of flag that that's something that if it starts on that discussion at an early point, I'm sus, So let's talk modifying source code, and don't worry, I know you're all gonna do it. I just want to set up some kind of general guidelines and things for that. So considerations when changing the source code is, first off, it's just how far off the beaten path are you going to get? Remember that if you aggressively change Unreal early, you have to live with that every time you do an engine migration. And that will probably seem fine until we add a really good optimization you just didn't know was going to come 6 months from now, and then you feel bad. So how far it's going to take you off the beaten path is pretty important. Whether that's something you can potentially kick down the road is worthy, especially for larger AAA teams that are on UDN. We officially support the last 2 versions of Unreal at any given time. So, the older and more out of date you get, the more trouble we have in helping you find what's going wrong in your projects. And next up is how are you documenting the changes? Just be really aggressive with this is our changes start here, our changes end here. Really, really aggressive on that. It's okay to over-comment it because you really need to catch all of them, or you just create other headaches for yourself. And the last one I want to just call out is, honestly, we see a lot of people engaging in engine changes that other people have done too. And quite often, if you look at the Unreal GitHub, not only can you get upcoming changes to Unreal, but you can also see pull requests and things that people have done themselves. So if someone else has tried to make that change, sometimes it's good to just look at that instead of going in blind. And often people only notice that when they go to commit it themselves, and they'll be like, And this is how I'm going to sell this to engineers. If we accept your changes, we have to deal with the problem. Because if you make a change to Unreal and it makes it faster, and you do a pull request to go back to Epic, you don't have to deal with migrating that to the next version of Unreal or the version after that or the version after that. That falls back on us. And I know there's probably an engineer from Epic in the audience who's going to throw something at me when I sell it that way. But I have good reflexes. I don't. I make games. So But no, it is a bit of a double-edged sword because we're not necessarily likely to take PRs, pull requests, for whole new features. Just because we do have to support them, so there needs to be kind of a more compelling reason for something that's really big. But like bug fixes, API exposures, just general performance improvements, that kind of thing. It can feel like death by 1,000 cuts when you're moving a whole bunch of different source code changes up. So if you're able to push them back to us and we agree, then that can just make your life a little bit easier. This is not a rule, and this goes back to one of the first slides that I had. It's not a rule, but it's just kind of to quote the castle, a vibe. The one Australian in the audience got me. Thank you. Basically, like when you're in early development, you really want to kind of avoid doing huge changes unless you really have deemed that, look, this is just a change that we're going to need. As it goes, try your best to kind of keep up with Unreal builds. It's okay if you don't. There are plenty of teams who jump more than one version when they're jumping up. It's normal. But it does make your life a little bit harder to do sometimes when you have to do multiple migrations in one go, and it can end up taking longer. Once you're kind of in that final year, my suggestion is generally it's fine to pump the brakes on getting Unreal Engine updates and instead start cherry picking changes. So looking at our GitHub and being like, this is the problem we have right now, I'll take that. And this is the problem we have right now. And that way you're just going to make sure that when your game goes out the door, it's the most stable it can be. And you haven't done that classic problem of, moving up a version and introducing whole new problems. Which I think is one of the strengths of Unreal, is being able to kind of just cherry pick those fixes, right? And then I guess for post-release, just really consider, as you start to make those changes in the final year and you're thinking about it all, considering early what you're expecting the tail on this project to look like. Because if you're going to be updating it for a long time, you may still want to be pulling in Unreal's changes for various reasons. But that needs to be a bigger discussion. But I do highlight that it's a good idea to have that midway through production as it's taking shape. I want to have some discussions on Blueprint and C++. And the first of those things is should something be in C++ or Blueprint? I know this feels like a beginner's conversation, but I have a different version of this conversation at every level of game development experience. It's just a common one, right? And I get it. But first off, just honestly, just set a paradigm for the team and stick with it. That's a really important aspect here, is just really knowing what the kind of general rule set is for this, and when you're trying to push things into BP or native. Keep anything that an artist or designer would need or want to control within blueprints if you can, is a general suggestion, unless there are really serious perf considerations and other aspects involved. Again, even though I'm using the words keep, I'm everything has a silent try to at the start of it. And finally, working with GAS, the game playability system, can be a nice kind of midpoint between C++ and Blueprint requirements. That said, I would suggest establishing a team policy to default to C++ for structs. Having structs defined natively, it could just be when they first came into Blueprint a long time ago, they would sometimes have issues. But honestly, just even for wider problems, just if it's defined natively, everyone can use them. You don't end up with weird multiple versions of the same struct that's like the C++ version and BP version. If this sounds like it's coming from a personal place, it's just I've had it too many times. It hurts. And generally, with multiple programming languages, thinking about the domain is really the most important part of that to me. And Blueprint has its strengths, C++ has its strengths, trying to figure out, what and where makes sense. And, we have good write-ups on this, and there's 1,001 YouTube videos that are probably at least 70% right on the topic. Sorry, is that too bitter? But there's a good time and a place for each. But I do think that an important element that doesn't come up enough in this discussion is ultimately the programmers can use the reflection system to kind of choose what to expose, to kind of have some guardrails for the rest of the team. We talk about Blueprint and C++ in a lot of these videos and these talks. And it's always oh, this is better for this and this is better for this. But, programmers creating systems that the Blueprint folks are inheriting from that pull in certain rule sets and logic with them can be a gentler way to handle that without feeling like you're kind of giving them the keys to the car and telling them to go wild, right? So keep that in mind. And finally, like on this topic, I just wanted to call out that like Blueprint versus C++ just makes it sound like they're at war with one another, you know, like, but in reality, they're just made to work with one another, and trying to embrace the strengths of both, I think is important. I really wanted to highlight this section just because, especially folks coming from proprietary engines to Unreal, often have very, very experienced reasoning for why they really prefer code, and it makes total sense to me. But it is something to really consider again strongly, and I'm that guy that's going to call that out again. And you know, when you are doing this, I brought up the optimization before. I don't know why I have a violent man shooting a gun to describe this picture. I swear it wasn't actually the vibe that I was trying to set for this. But refactoring the code like into C++ is fine. But just do your best to do it at a time where it's not going to really disrupt the like game designers working with that kind of code and stuff like that. Cool. And I guess what I'm also wanted to get at on the Blueprint side is that while it is in Blueprint, there's a good chance that work can be distributed across different parts of the team. And again, this is a bit of a call out to producers and tech directors that like when something is in Blueprint, there's a higher chance that a game designer can fix an issue without it becoming like a specific programming team who's already overburdened. You know, and having their job as well. So when a game designer can work on it, or you know, other folks can, it is pretty important from a production standpoint that there's other reasons there to keep in mind. And I want to follow that up with that there's a lot of tooling in Unreal that can be done specifically in Blueprint. So scriptable tools are great for making entire modes. So, you know, if you want to have AI placement mode, pathing placement modes, and stuff like that for your game, it's a really good thing to have. Editor utilities for simple right-click scripts, editor utility widgets if you want to have little UMG aspects, construction scripts for like per actor logic. All of these can be done with Blueprint. Excuse me. All of these can be done with Blueprint, and because of that, I strongly recommend that teaching Blueprint basics to everyone on the team can help productivity, because you move tools that never actually end up in the shipped game. You know what I mean? Like if it's literally just creating an actor and assigning properties to it, you don't have to be as afraid of you know, the different parts of the non-programming team making things if ultimately it's just essentially glorified shortcuts for them. You know, like so. Try and consider having Blueprint taught to everyone, because it will make a lot of their daily tasks easier. And if they're really getting into Blueprint, you might want to teach them some C++. And obviously, you know, they're going to be like, yeah, cool story, Chris, that sounds scary. And I get why. But just remember that you can use the Blueprint header tool to actually look at what a C++ header file should look like for a Blueprint. So moving stuff from Blueprint to C++, this is kind of a nice toe in the water if you're not historically a programmer, to at least have an idea of how certain variables and functions should be declared, which is honestly, in my opinion, kind of like the hard part when you're adjusting between them. And that's useful. On the construction script front that I mentioned, construction scripts are baked into the map, and they don't incur a runtime cost unless the actor is spawned at runtime. But we do see like overuse of construction scripts. And my general suggestion is like simple instructions that you can confidently cache, and assets that don't need to refresh when other assets around them are really good for construction scripts. In construction scripts, though, you want to try and avoid logic that artists aren't going to aggressively tweak, or you're just adding a bunch of overhead and things that could be problems. Logic involving spawning the actor at runtime, assets relying on other assets that can cause dependency issues are a big call out here, child actors, and elements that may be changed at level load. One thing that has been starting to pop up, and I think there's good arguments for it, is we have seen more and more people using PCG components instead of construction scripts for the visual logic of certain things. An advantage of that is it actually splits out the visual asset logic with the Blueprint logic, and that means two people can modify that at the same time without having file contention. You know, like if I have a bridge, An artist can go wild on the PCG setup that's like scattering objects on the bridge and making it look pretty and baking stuff out, whatever. And at the same time, like the pathing logic or whatever else can be worked on by a programmer without necessarily feeling like only one of you can play with that at the same time. I want to touch on some pipeline and world building considerations. As we do, I want to just do a big call out to check out the world building guide. The world building team at Unreal are fantastic, and they're really, really passionate about helping people. But it turns out you can make so many mistakes world building. This sounds like it's a metaphor, but like, a lot can go wrong on the world building front, right? And they've done their best. That this guide is not only like best practices, but it does aggressively go into like frequently asked questions, common things that we see popping up on UDN, and all sorts of like ways to get around them. So this world building guide should be one of the first ports of call for any team that's embarking on a large project in Unreal. It is really good. Please make sure you check it out. Enough of the cameras have gone down again that you've all got the QR code. Thank you for that. So I want to do a couple of world building callouts. I have a good talk on this called Building Bigger from Unreal Fest New Orleans. Whenever that was, a year and a half ago. I'm looking at the Unreal people in the back. Andrew won't help me. Okay. And yeah, if you want to go into the world building best practices, that's a pretty good talk. But honestly, that guide is a living, breathing document that's always being updated, and that is more up to date. So, grid setup. When you start production, general advice is start with a single grid. Your grid size is going to be controlling where things stream. So the bigger it is, the more stuff that's going to stream in at once. There's a few callouts that I just wanted to have on this. First off is that it'll probably change during production. And like, despite you wanting it to be a certain way, it will probably change. Keeping it in mind and like, as you're building stuff in the world, trying to build vaguely to the grid will make your life a lot easier. Like, if I'm going to put a village here and it's going to be 30% in one grid cell and 70% in the other, if I can find a reasonable enough, setup that I can move that grid just a little bit to the right to the point that it's all basically encompassed in one grid cell, that might be really good for our performance that we're going to have for streaming stuff in, So designing around the grid, if you can, is good. And I'm going to get into the loose hierarchical grid in a little bit to explain why that's not always the case. But one thing that is an important call out on this front is ultimately any large team that's working with big open worlds in Unreal, I strongly recommend you have one person whose thing is caring about the grid and basically like flagging things to be aware of during production. Just give them a cool name, call them a grid lord or something, and they'll feel better about it. You know what I mean? Not my job description. You're the grid lord. Okay, I'm in. But definitely like have someone with that role. I want to flag that actors can be put in secondary grids as well. You don't have to have just one grid in the world. And a cool part of that is you can handle the streaming of your buildings on one big grid, but you can handle the streaming of props and stuff in the world on a much smaller grid that's only going to happen when you're like getting closer to villages or buildings or whatever. So like having multiple grids can be a good way to approach some of this. You really want to not do that too aggressively. But if you are going to have like diverging densities, streaming distances, that kind of thing that you think is really going to be split up, a secondary grid can be a good approach for that. One thing that I want to flag on this front is that each cell of a grid containing at least one actor produces a streaming level, and each unique runtime data layer combination on actors in that grid cell. So you actually can get quite a lot of permutations quite quickly if you start doing a whole bunch of grids. So I generally suggest trying to keep it to a lower number of grids if you can. And that brings me to the loose hierarchical grid. This came in with 5.4 and allows for fuzzy placement logic. How this works is this. If the grid cell was going to be here and there's like one actor all on its lonesome slightly to the right that's pretty much not going to get snapped up by anything else, the grid will just be like, all right, I'll take you as well. Do you know what I mean? So it'll kind of like encompass stuff that's pretty close but like just fell out of bounds. Which is really useful. It kind of keeps your streaming logic a bit more consolidated, and I think it's good. However, if you created your project before 5.4, the setting that you have is going to be the old strict hard grid placement that was there. And you can use a commandlet to convert from one to the other, but it does mean that you'll be using, the one from the olden days, 5.3. Other things to just be aware on that front are a level instance placed into a map will be automatically broken up and sorted into correct streaming grid cells under the hood. So if you are using level instances and you're just plonking them down, don't be afraid. Unreal will actually split them up. Placing it in a level instance like this then becomes like, if my village or town or whatever is a level instance, it kind of becomes more of an organizational outcome than a performance-driven one for the most part. And I wanted to bring this up because it does come up in a lot of meetings of like, is this good practice? And unfortunately, the answer is it depends. But it's really, it depends from organizational reasons rather than perf hits. However, packed level actors are a form of level instance that we condense the whole level into a blueprint, and that it instances all of those meshes, right? And the problem with that is that packed level actors, when placed into the map, are an actor with huge bounds, and they can be a really common issue for streaming. So if you're finding you're getting streaming hitches, one common thing that we see is people using packed level actors for like the forest, at which point they're bringing in the entire forest with like data sets of just like every possible tree. And that can be quite a lot in one go, especially because it's got huge bounds, which can kind of play havoc sometimes with which grid cell it was meant to end up in, because technically the actor is just enormous. So I wanted to flag PLAs as an edge case there that catch people off guard. However, whenever I get in the discussion of streaming, everyone thinks of streaming stuff in, but they don't think of necessarily what if the stuff just didn't exist until it had to. And for that, I strongly recommend your teams look at hierarchical generation within PCG. Basically, what we can do is this. While normally we're streaming in actors and stuff in the world from whatever distances we have, hierarchical generation means that PCG it breaks its logic into grid cells, and it'll say, when I'm 50 meters away from here, don't make me convert that to Unreal units. When I'm 50 meters away from here, that's when I want to start generating this next bit of logic. And when I'm 100 meters from here, that's when I'll do the next bit of logic. And what this means is, instead of actually streaming it in from the entire grid cell, PCG is instead just going to be like basically treating it as very smart landscape grass. So landscape grass doesn't exist until you get close enough for it to do it. You can just do the same thing essentially with like bushes and smaller rocks, debris, and that kind of stuff. But because it can be done on a much kind of tighter scale without necessarily needing to be cached at all, you do have different savings in different parts of that, and it can get rid of it pretty quick too. So I strongly recommend looking at PCG as an alternative, because it'll be happening async in background rather than happening as the core data loading kicks in at the same time. One that I wanted to touch on here that is not super well used right now, but your team may want to investigate from an engineering standpoint, is the level streaming persistency plugin, which is still in like an earlier state. I'm not sure what the plans are for that, so maybe it's the final state. I should have asked the team, sorry. But essentially what this does, it allows you to specify actors and variables, and those variables get cached. So this is not for like, hey, there was a big battle, when I leave and come back, all of the bodies and stuff are still there. Sorry, I went grim on that. It's day 4 of GDC. I've had the more adorable one on day 1, right? But like, now I'm just thinking of what the analogy would be. Sorry. Yeah, so it's not about having all of that data maintained. Instead, what it is more about like, you were in a cave and you opened a bunch of doors and things like that. I'm not going to leave the cave and come back and all the doors just magically closed to themselves, So it's kind of more about like smaller changes and things that you may have affecting the world. But it is there, and some of the engineers in the room may want to at least investigate how that approach works, because it does need to be defined through configs, and it's not super well known. So I kind of wanted to call it out. And on the topic of things that I think are really important on this front, instance actors. This comes up in so many of my meetings, because everyone's like, we want to create a big open world. And then they get to the problem of like, we don't want our open world to feel desolate. You know what I mean? Like, they want to have some life in this open world. They want to have things that can be interesting. So Instance actors is really, really cool because how it works is it runs Unreal Engine's mass entity system under the hood, which for anyone that's unfamiliar with it is how we handle like a whole lot of stuff at the same time. It's really, really good for handling like city simulations and stuff like that. The problem is that normally when you deal with a mass entity, you need to deal with it in a way that's not conventional to like the actor approach that we're used to doing in Unreal. So everyone kind of treats this as a Boolean decision. It's like mass or it's not mass. Instance actors is really cool because what it actually does is it runs a mass entity system until you either get within a certain distance or you trace into it. And if I run a trace into like a mass entity that is a tree that's growing fruit over time or something, the instance actors plugin is really cool because when you trace into the tree, it will actually create an actor with the mass logic in there and return a reference to the actor that it just created as if it had always been the actor. And what's really good about that is like it's kind of invisibly switching between the really performant thing and the more practical thing that folks are used to working with, which is great. I don't expect anyone to really use this out of the box, but it is at least a good framework for you to kind of start looking at bringing more into your worlds. So I think that's really, really powerful. So please consider it when thinking of like how you want to have more interactivity and interesting things within your world. What to use and when. So if you've got general actors, like just regular everyday actors, you can use them just in isolated aspects within core regions. If you're frequently placing these, like you can reduce the chaos by setting hide unloaded actors on your world outliner. It'll just be easier to not have like a ton there. Level instances are for whenever you have like duplicated modifiable actor collections, guard towers, buildings, that kind of stuff. Packed level actors are if you're going to have a ton of instance meshes inside of an actor. So this is good for like pre-placed ferns or patches of stuff, but not like an entire forest. I really want to stress that one. And PCG with high gen is what you would use for like grass, foliage, that kind of stuff. And that's kind of picking up the slack as well. So there's a bunch of different systems that are handling different parts of streaming. And, often the reason for a hitch is we really just see too much being loaded at the same time. So we're just kind of playing a game here of splitting that up as much as we can. And it's likely that your two biggest sources of potential hitches are going to be streaming stuff in, as I mentioned, and PSOs, which is pipeline state objects. I'm not going to go into PSOs because it is kind of its entire topic. But I will say that like we handle PSO pre-caching. Oh, sorry, I'll step back a bit. Whenever you render a material or an effect or anything like that for the first time, Unreal kind of has to build some logic about how to do that, right? And that's what a PSO is. So what we used to do is we had bundles, and you can still use bundles. And bundles were, you could play the game and basically record. Unreal would record under the hood, this is when these things happened. And that means that when it goes to like trigger something, it's much quicker to kind of load it in. And that works for a single player game that you can be kind of like reasonably confident when a bad guy is going to first appear and stuff like that. But if you're playing a game like Fortnite, where you don't know which corner of the island they're going to drop in with different biomes and things like that, bundles don't really work. And that's where the PSO side of things comes in. We have a system called PSO pre-caching, which came in with 5.3. If you're making any game that's 5.4 or beyond, we generally recommend using PSO pre-caching. If you want to test what your game is going to be like for the first time a user plays it because you're trying to debug PSO pre-caching, there's a great CVar that you can use called r.psoprecache.validation equals 2. And what that will basically do is just like nuke any of the ones that it's already generated and be like, we're going to run from a clean slate and you will experience all the hitches that a new user would experience as well. Okay. Now, there's some really good documentation on this, so I'm not going to go into it too much today because we're running tight of time. So I'm just going to link you to those. The first of those is a great blog post on the subject, which is here. I'll give you like 5 seconds. Sorry, I realize I got like 9 minutes. We can do this. There's only 20 slides left. The next one is documentation for PSO pre-caching. This is the actual docs, and this is really, really thorough. And this is like how to set up loading screens to like pre-cache a bunch of stuff that you're expecting, how to extend the engine to include stuff that Unreal by default doesn't expect to be brought in because of other stuff, et cetera, et cetera. I wanted to flag custom thumbnails because it's something that doesn't matter too much when you have like one VFX artist or like one environmental artist who knows what's going on. But at any point, you can right-click on a thumbnail and click Capture, and it will record what's currently on screen as the icon. It's just good practice to get your artists into early because, you know, like projects end up with thousands and thousands and thousands of assets, right? And the difference between the unhelpful icon in the bottom right versus like the picture of the portal that I made are pretty substantial. Data validation plugin, for anyone that's unaware of it, you can set up rule sets for how Unreal should handle. Basically, when you go to save an asset, you can be like, I want you to run this script first and make sure they haven't done anything naughty. So you can set that up to be like, hey, I want to make sure the material doesn't have these things that we've said you can't do if it's in the characters folder, or I want to make sure it's got this type of file name convention or whatever else it may be. But setting these up and establishing these early is pretty important, and you can catch stuff and just kind of stop problems before they become everyone's problems, you know? Just being able to point blank be like, you have too many polys. We said that we would never add something over 2 million. What have you done? You can even make that the message if you want. Is really helpful. The other side of that is Interchange. So Interchange allows you to catch, you can set up custom import dialogues in Unreal. And this is a pretty cool workflow where you can set it up to be like, hey, look, we've caught an FBX file coming in from a weapons folder. And therefore, I'm going to give them a specific import weapon dialog that we've set up that's like, here are the only checkboxes you're ever allowed to change. And then you can set that up to then automatically import that to a data table or to potentially create a blueprint or assign stuff, whatever it is that you need to do. But it's pretty cool that you can kind of set up that logic in general to work with. A couple of things to keep an eye out for in my last 7 minutes. We're going to speed through this. Keep an eye on Fortnite. I know that sounds like I'm after your V-Bucks. Not denying it. No, keep an eye on Fortnite because, like, honestly, as an Unreal Engine developer, Epic is also an Unreal Engine developer with, you know, with Fortnite, right? So we're always stress testing stuff, and it's actually a really good idea to just keep an eye on like the features we've been bringing in with new seasons, because like we've done everything from like swapping out the physics engine in a patch on Fortnite to, you know, introducing Nanite and Lumen, and then we've had accompanying blog posts to say what our discoveries were during that. So keep an eye on that. It really will help you out. I strongly recommend it. An hour of teaching Unreal Engine insights to your team, especially the ones who don't usually do it, can really pay dividends because it allows them to just identify bugs without it having to go through an entire team. Even if you think that's too much Unreal Insights, at least show them how to use the GPU profiler, which is Control-Shift-, and that will just often, the number of times I've gone to fix a problem and like I've just hit that and been like, you have a scene capture actor in the world that you used for a marketing shot that you just forgot about, you know, or like one person thought they should add a security camera to the world and now you're rendering the entire world twice. Catching that is very easy. Chaos Visual Debugger is something I wanted to flag because it came in with Unreal, but not many folks know about it because it's kind of recent. If you are trying to debug larger scale collisions, and I wanted to bring this up in this AAA talk because of how frequently AAA devs have like custom movement setups that this is the kind of stuff they're trying to track down. Just be aware that this exists. You can record the collisions and see what was causing different interactions at different times. It's a bit of a pathway to go down. Child actor components, I bring them up because they can be somewhat untrustworthy. Out of context, I feel sad. But yeah, child actors can be a little bit untrustworthy. They're good, but they can end up with some dependency issues because it's like one actor spawning another actor that can potentially re-reference the first actor, and you can get a little bit out of place with it. So my general suggestion is dialing them back if you can. Timelines, just remember that timelines in Blueprint are components. So having 20 of them in a blueprint means 20 additional components that have been like put in there. It's okay to have 1 or 2 things like that here and there, but it can get pretty heavy, especially if it becomes like a regular workflow that you're leaning into. In general, avoid hard references if you can. This is common advice, but it happens to everyone at every level of engineering, from indies to the mythical quad A developer. So it does happen. And in one thing, having a hard reference to another, Unreal's going to load them both in. And if that's got a hard reference to another thing, it'll load that in, right? And the problem is that happens a lot, especially in the context of UMG. Because you'll have a main menu that might have lists of all of the items in the game, and then all of the items are getting pulled in. So whenever they hit pause, it's like bringing in a whole bunch of stuff. Just being aware that UMG can be a bit of a culprit on that front. A few things I just want to call out are you can set up class redirects if you are swapping out Blueprint to C++. Just wanted to bring this up on the deprecation discussion from before of like not being afraid to use Blueprint. This is really nice for just when you are migrating from one to the other. You can just start to tell Unreal to kind of redirect its logic. I also want to flag that Niagara has its own entire versioning system built in. So you can actually set it up that you've got ns_fire, but if they add that in the year 2026, it might be using ns_fire version 3, but it won't break all of the existing fires that are already in the game. So leveraging the versioning system there is a good idea. Same thing for Blueprint. There's deprecation classes and variables you can set up. C++ allows for deprecation through custom metadata specifiers too. We're in the final track here. So the other thing I want to call out is just ensure that you've set up your scalability settings and device profiles early and that the team know how to use them. I know my reference here is talking about _PS5, but that's underscore any console. You know what I mean? Like if you have _switch version on a texture, quite often I'll be like, is that really what you meant to do? Or is this meant to be a specific quality level? And you've got someone doing some kind of weird stuff that's not sticking to the standardized scalability settings that would be there. I also want to flag that post-process volumes override the graphics settings in the scalability settings. So quite frequently, you've set up scalability settings that are like, here are the things that we allow on this console. And then someone's like, yeah, but it looks pretty if I turn this on. And it's a good counter argument, but it's very easy to miss. And you need to make sure that your team is aware of the repercussions of using those post-processing volumes incorrectly. Okay, we did it. Wonderful. So, on that note, thank you all very much for your time. I hope this has been useful. I know it was a bit of a whirlwind because we went through a lot and I'm just really jet lagged. But I hope this has been useful for everyone. I'm keen to hear about some of the stuff that you're doing. I was told to remind everyone that there's some sort of feedback form that you're meant to fill out so that is my due diligence covered. But yeah, in the meantime, thank you all very much for your time. My name is Chris Murphy, and I hope you make some cool stuff in Unreal.